Hello wonderful person, this is Anton, and this is a sun, or the sun, orbiting a black hole, and being destroyed by one as well. Now in today's video I wanted to actually see if we can turn everything in our solar system into a little black hole, and find out what actually happens when you turn things into black holes, and also as you turn things into black holes. So this is going to be quite an interesting experiment. So let's find out what actually happens. Welcome to What the Math. So our sun got shredded by this black hole, but that's not exactly what's going to happen when we begin a new simulation here. We're going to open a completely new solar system simulation, the one you start the game with when you just open the game. Now in this simulation, when you just begin, everything is either a planet, a star like the sun, an asteroid, or a dwarf planet. We're going to actually get rid of some of the things that we don't need, but before we do that, let's begin by talking about, so what exactly is a black hole and how exactly do you turn things into black holes? Well, in reality, nothing in our solar system will ever become a black hole unless it gets sucked into one and adds to an existing black hole. So even our sun will not actually become one. It will just become a white dwarf sometime, something like 6 to 7 billion years from now. Now, we can still make a black hole in this game, though, by essentially reducing the size of this object while maintaining its mass. So essentially, a black hole is something that has an extremely high density. Essentially when something collapses to the point of what's known as singularity and creates this point in space, or basically a hole in space where nothing can escape it, including light. We can actually do this in the game by pressing this, locking the mass, and reducing the size of an object. Now as you reduce the size of the sun, you'll notice that both the temperature and the luminosity start decreasing. And at some point it's actually going to be relatively dark, but then it might also start changing its other parameters as well. And here we're looking at things like escape velocity and also surface gravity. And as soon as the escape velocity actually reaches the speed of light, oh no, that's not exactly what I wanted to do, I returned it back to normal. Alright, let's try this again. So as soon as the escape velocity reaches the speed of light, that's when you know you're creating something that's possibly similar to a black hole. Now, interestingly, as I reduce the size here, and it's already smaller than our planet Earth right now, you'll notice that it starts moving around a lot. As a matter of fact, you'll notice that it actually kind of circles around something. So if I were to accelerate time here, you would see that it actually is moving. Now, why exactly is it moving? Well, that's because it was always moving. It has a barycenter, basically a center of gravity with Jupiter. Jupiter is so massive that it actually creates a barycenter with our sun, but because the sun is so big, we don't really see it. But now that the sun is really small, it's much easier to see the barycenter, and that's why the sun is actually moving. So, we're almost there. We're going to reduce the size to about 4-ish kilometers, and that's when our sun should technically become a black hole. And so at 30 kilometers in radius, the escape velocity is already at 100,000 kilometers per second. It's a third of the speed of light, and we're slowly approaching that speed of light value, which will turn this into a black hole. Now obviously this is not very realistic, but it's possible in the game. Alright, so we're almost there. 4 kilometers radius, and the escape velocity is 260,000. 270, 280, 290, and here we go. So as soon as this value becomes speed of light, this becomes a black hole. So radius right now is about 3 kilometers. This is smaller than the smallest possible neutron star. And so if we were to compare this to things like Crab Pulsar, for example, it is actually much smaller than it. So there you go. That's how small our sun is now. But the thing is, since I turned the sun as a black hole first, I won't be able to see any other planets now. Or at least they'll be kind of dark. Interestingly though, all of our planets have now frozen because they don't really get any light from the sun anymore. So maybe we'll go back and do the planets first and then do the sun, because I actually would like to see how these black holes look like when you turn them into black holes with the sun still around. So let's actually do this really quickly. And we're going to start our black hole exploration with Jupiter. So Jupiter is going to be the first object we're going to turn into a planetary black hole. Once again, this is not a very realistic concept, but it is possible in the game. So let's start by decreasing the size of Jupiter to about 100 kilometers in radius. And you'll notice that the density jumped dramatically. Everything basically decreased in size, but it still looks like Jupiter. It still looks exactly like it did before, just in a much smaller sort of proportions. And escape velocity is only about 3,000 kilometers per second right now. So this is going to be a very small black hole. So because the mass of Jupiter is much smaller than the mass of the Sun, it's very likely that this black hole is not even going to be a kilometer in size. It's possibly going to be a few meters across. And we're going to find out how big it is in a few seconds, as soon as it reaches the escape velocity of the speed of light. And so right now Jupiter is about 100 meters in radius, which is about 300 feet, and its escape velocity is 50,000 kilometers per second. So it looks like we're going to be at a very small size, possibly even a size of a person. This is how small this black hole will be once we actually establish it. And we're at 3 meters in radius now, 2 meters, and there we go. So it was about 2.8 meters. So that's just over about 7 feet, 8 feet. So a little bit bigger than a person, I guess size of a giraffe or something. So we can actually compare the size of Jupiter black hole, which I'm going to name it as that. Jupiter black hole. This is basically comparable to some of these human-based objects, like for example the police box. So there's the police box in comparison to the Jupiter black hole. Now, in reality, if we were to actually one day somehow manage to create a black hole out of Jupiter, it would not live for very long. It would only survive for something like a few seconds or maybe a minute, because the size of this black hole would actually not be able to be maintained, and it would essentially evaporate almost entirely within a few minutes. It would be not a very stable black hole at all, because it just doesn't have enough mass, unfortunately. All right, so let's do the same to Saturn, and I'm guessing that in case of Saturn, the size is actually going to be very close to a size of a person. So let's actually change it manually to 2 meters in radius. And looks like it's still not a black hole yet. Let's see how small of a person it's going to be. We're going to decrease this until it does become a black hole right around now. All right, 0.8 meters. That's about 84 centimeters. That is really nothing. That's only like 3 feet. It's a very tiny person. That's basically, I don't want to say midget, but it's a midget. Anyway, so this black hole is much smaller than the Jupiter black hole, and would also survive for much shorter time. It would only last a few seconds if this was actually real. Somehow Saturn turned into a black hole, it would not be around for very long. Now let's do Neptune and Uranus really quickly. We're going to go through these relatively fast. We're going to basically reduce their size manually, possibly making this into a really small black hole really quickly. And it looks like the size of Neptune is only 15 centimeters, which is really tiny actually. This is only like what, 6 or so inches in size, or at least in radius, which basically means that you can possibly place this on your table if your table could withstand black holes. And Uranus is going to be probably very similar to this, so we're going to lock its size, maybe a little bit smaller because it is a much smaller object. And so here we're going to reduce this to about 12 or 13 centimeters. So 13 centimeters, 15 centimeters, 84 centimeters for Saturn, and about 2.8 meters for Jupiter. We're not going to do other objects like dwarf planets and such, because they're obviously going to be much smaller, but we are going to do terrestrial planets, starting with our favorite neighbor, Mars. So Mars, how big of a black hole are you going to be if we condense you into a tiny piece? So let's do this manually first. Let's actually see how Mars shrinks as we reduce its size and keep its mass constant. Although interestingly, this also increases its surface temperature. As a matter of fact, if you look at the surface temperature right here, it's jumping up dramatically. So I'm kind of curious what's going to happen as I reduce the size here, because it seems to be actually terraforming this beautiful neighboring planet. Look at that. We're now at a surface temperature of over 100 degrees Celsius. That's actually very impressive. And the size of Mars here is about, or was about 100 kilometers for that to happen. And look at this. It's actually now acquiring some kind of an atmosphere and also is burning. That is beautiful. I really did not expect that at all. So because of the increase in density, this beautiful planet is actually becoming a molten tiny ball of fire. And that's going to be very interesting to observe because it's going to be a tiny ball. It's going to be like a marble-sized fireball. So I've reduced the size to about 2 meters now. The temperature of this object that used to be known as Mars is hotter than most stars. It's basically a ridiculous 78,000 degrees Celsius. That is really, really high. And it's not even close to becoming a black hole yet. Its density is really, really high. Its escape velocity is about 1/30th of the speed of light. But it's slowly heading there. It's slowly becoming the black hole we wanted it to create. But the temperature here is ridiculous. This is already close to 200,000 degrees. I wonder if we'll be able to reach 1,000,000 degrees before it becomes a black hole. And look at that, at 4.5 millimeters, we've actually reached 1,000,000 degrees Celsius. That is a very, very hot object. It's going to be really tiny. It's even going to be smaller than I thought it would be. This is not even a marble. This is just a really tiny fingernail-like structure. And here we go. It's now... Oh, that's interesting. Look at that. I found a bug. What is that? That's not a black hole. That is not a black hole at all. Now it is. So there was a short bug there for a second. But there's our Mars as a black hole. Its size is about 1 millimeter. So that's essentially the size of a fingernail. And I'm talking about the white part of your fingernail, the part that some of us bite sometimes. So that's how small it is. It's very, very, very tiny. It is ridiculous. I can't even see it actually. It's totally invisible. Oh, here it is. No, here it's not. And so here you go. This is our Martian black hole that seems to behave very strangely. It seems to be either bugged out or it might be some kind of a Schrodinger's black hole, like Schrodinger's cat. It exists and doesn't exist at the same time. So there you go. That's pretty cool. Anyway, let's go to Earth, Venus, and Mercury and do the same thing. Starting with Mercury, we're just going to reduce its size right away to 5 millimeters and decrease its size until it reaches the speed of light escape velocity and becomes a black hole that's about half the size of Mars. So there is our Mercury black hole. It's somewhere right here. Once again, also invisible and partially obscured by the bug that I just discovered. So this is going to be Mercury black hole. Next is Venus, so let's reduce its size again, and we're going to, oh, look at that, look at how transformation, whoa, look at the transformation, that is insane. I did not expect that. It suddenly started to transform almost instantly, basically increasing the temperature dramatically, and the density is jumping up as well, and this is still at a very large size. This was only about 1,000 kilometers in radius. So looks like this might be actually the hottest object we'll be able to create before it turns into a black hole. And just as I thought, so at only centimeters in size, it's already over 2 million degrees Celsius in temperature. This is the hottest object I've created in the game ever. This is ridiculous. This is hotter than the inside of some stars, actually. And here we go. We're going to be able to create a black hole that's about... It's probably going to be bigger than Mars, but definitely not as big as other objects. And right around here at about 1 centimeter, maybe a little bit less than 1 centimeter, a few millimeters, I guess. Okay, so it looks like it was about 7 millimeters. 7 millimeters in size, that is essentially your Venus black hole. And last but not least is, of course, our own Earth, and then we're going to finish with the Sun. So let's see what happens to Earth as we decrease its size. And as we essentially do exactly the same thing we just did to Mercury, Venus, and Mars. So I wonder if the temperature here changes, and it looks like it doesn't actually change. It still stays at the same 15 degrees Celsius. But this is basically becoming a shrunk Earth world. And look at that, it seems to be covering in snow. There seems to be more snow everywhere because we're decreasing the size, and I guess the snow can distribute itself much easier now, because the temperature is definitely not changing. So this is only about 10 centimeters in radius. The temperature definitely hasn't changed at all. Interestingly, unlike Mars and Venus, Earth doesn't seem to acquire any temperature, but it does acquire density and obviously acquire surface, or escape velocity, that is, and surface gravity. So here, what is going to be our size at the end? And the final size is about, interesting, it's about 9 millimeters. That seems a little bit smaller than what Venus was. Or actually, never mind. Venus was 7 millimeters, and this is 8 millimeters. All right, perfect. And the last but not least is, of course, the Sun. So let's change the Sun into a black hole. And there we go. So there is our black hole system. Basically everything here, with the exception of some of these asteroids and dwarf planets that we're going to remove right now, is essentially a black hole. I'm going to actually go into the chart view just to show you how all of this compares in terms of size. And so this is the chart mode where you can actually compare things by size. And the first object here is Pluto because we didn't remove it. So this is the largest dwarf planet. And as we go down, we'll get to see other asteroids, other larger rocks in space, and some of the other minor planets and dwarf planets, until we reach the end, where we have our tiny, tiny, tiny black hole known as the Sun. And there it is. I'm going to try to zoom in just to show you how tiny it is. There's the Sun, and right there's the other black holes that we've just created. So this is how tiny they are. Ridiculously small. Smaller than anything else you can kind of imagine in space. And so that's essentially how the system would look like if everything in our solar system turned into a black hole. So notice how none of the orbits changed. All of the orbits are exactly the same as they were. The only difference is, of course, that these are much, much, much smaller objects. They produce no light other than Hawking radiation, and everything else stays the same. So if the Sun or anything else in our solar system became a black hole, nobody would really notice, other than, of course, us not seeing anything. And so there you go, that's what a solar system with everything as a black hole looks like. And for some reason, Venus has this unusual orbital ring around it. I don't really know why that happened, but it is there. Everything else, though, is still in the same orbit as it was. And anyway, so I hope you learned something from this video. Now you know a little bit more about what black holes are, how they look, and what they actually represent. But most importantly, what would happen if everything in our solar system became a black hole. And if you enjoyed this video, don't forget to subscribe. Don't forget to share this with your friends or someone who enjoys learning through video games. And I'll see you guys in the next video. Come back tomorrow to learn something completely new. Anyway, space out. See you later. Bye-bye. It's an experiment. So let's find out what actually happens. Welcome to What the Math. So our sun got shredded by this black hole, but that's not exactly what's going to happen when we begin a new simulation here. We're going to open... Well, in reality, nothing in our solar system will ever become a black hole unless it gets sucked into one and adds to an existing black hole. So even our sun will not actually become one. It will just become a white dwarf sometime, something like 6 to 7 billion years from now. Now, we can still make a black hole in this game, though, by essentially reducing the size of this object while maintaining its... Hello, wonderful person, this is Anton, and this is a sun, or the sun, orbiting a black hole and being destroyed by one as well. Now, in today's video, I wanted to actually see if we can turn everything in our solar system into a little black hole and find out what actually happens when you turn things into black holes, and also as you turn things into black holes. So this is going to be quite an interesting, a completely new solar system simulation, the one you start the game with when you just open the game. Now in this simulation, when you just begin, everything is either a planet, a star like the sun, an asteroid, or a dwarf planet. We're going to actually get rid of some of the things that we don't need, but before we do that, let's begin by talking about, so what exactly is a black hole and how exactly do you turn things into black holes? Mass. So essentially, a black hole is something that has an extremely high density. It essentially when something collapses to the point of what's known as singularity and creates this point in space, or basically a hole in space where nothing can escape it, including light. We can actually do this in a game by pressing this, locking the